Okay, Algebra 2, Lesson 6.6, we're using a graphing calculator to find x-intercepts, which we're also going to call zeros, and also maximums and minimums. And you can see that's our learning target. I can use a graphing calculator to find the real zeros, the x-intercepts. So tell you what, we're going to type in this equation rather than using your TI-84. Like I said, I wanted you to have your Chromebook out. Let's get you over to a website. And the website that I'd like for you to go to is desmos.com. DESMOS.com. And definitely that's something we're going to use a lot. It's way easier to use than your graphing calculator. So DESMOS.com. And as soon as you go there, it's going to say start graphing. And the hardest part, to tell you the truth, is just getting it typed in. So go to desmos.com. I'm going to go to start graphing. And then it says go ahead and type this thing in here. You could type in, I think you need y equals, and then you'll have x. But to raise up to a power, if you go above the 6, shift 6 is the caret. That's how you're going to go up high. That's x to the 4th. Shift and then hit 6. That's where your caret is. Hit the right arrow to bring it down. We'll say minus x. Now I need a power again. Shift 6. Bump that up to a 3. Right arrow. We'll say minus a 2x. And then I'm going to, again, keep hitting shift 6 to go up to a power. And you just keep hitting that right arrow to bring your term back down so that you can write things out. Look, guys, right now, we've got everything graphed. This is it. And the real cool thing is, just looking at this picture, how many times does it look like we're crossing the x-axis? Well, hopefully you can see right here these gray dots. These gray dots are showing you what's going on. One of them would be 0.481, comma 0. Just putting your cursor over it, you're going to get that. Now, that's one of your zeros, this x value. But we're going to go to the nearest hundredth. So I'm going to write 0.48. I'm going to come over here and say 0.48. But there's another one. I'm going to go back up here. Oopsie daisies. Let's see, where'd that go? Let's see here. It's over here. Sorry. And, the other one would be 2.08. Now, it's not rounding to the nearest hundredth, but you can see those are your x-intercepts. And that's all you're going to have to type in for Alex. Look how nice and easy it is. Way less button pushing than what you normally would be doing. Okay, so that hopefully is going to really be a huge help for you. And it's just a matter of being patient enough to get everything typed out. Okay, we doing okay? Yeah. All right, so zeros mean x-intercepts. You get it graphed. They're even going to give you the gray dots to say, hey, look here. Sometimes kids will say, well, wait, they also have a gray dot down below here. That, by the way, is a minimum point. That's where we're going next. They're not asking for that right here, but that's called extrema. And that's why this website is so powerful. It makes these problems way, way easier for you guys. All you got to do is get it typed in. Extrema will be the biggest or the lowest points. And, you just have to get that thing typed in, and Desmos will take care of the rest. So a low point would be the low point. Local min would be relative to all the points. It's the lowest point. Local max, you could have the highest point. And again, we're going to go to the nearest hundredth. So here we go again, guys. You want to know what you just got to be patient with is getting this thing typed out. Now look, if you know that you're typing out x to the 4th minus 3x cubed, you don't have to erase everything. You could just go back in and just make slight changes. That's another really cool part about using Desmos. I'm making minor changes right here to, oopsie daisies, there I just did it. You can see let's see, can we undo that? Look at that. Even if you make a mistake, you can hit that undo arrow, and that's pretty cool. So don't even be afraid if you make a mistake. I just made one. I'm really happy that happened. Okay, but this is maybe the biggest time constraint for you, just getting this typed in. And you can see what they're asking for in this problem. They're actually asking for you to find, let's see, what are they asking you to find? The local min. They want all the low points. And as you can see, there are a couple of them. There's this one right here. This is a low point. 2.16, comma, negative 4.17. So I'm going to type that in. 2.16 and negative 4.17. That's one of them. This makes life so much easier. You know, you don't have to worry about having to do as much button pushing. But is there another low point? Hopefully you can see this other gray point. They're really helping you out here. Negative 0.79. Now be careful. We've got to round this last part. That's negative 7.495. What would that round to 2 decimal places? Negative 7.50, right? Negative 0.79 and negative 7.50. So we just got to get that typed in, and then we're good to go, because we have to go to 2 decimal places. We're looking just for minimums. I do want to point out that there was another gray point that's up here. Don't put this down. That's your maximum point. They're asking, you could also find x-intercepts or zeros. You're not even asked to do that. Okay? So at this point, we just have one last problem that we're going to take a look at. Let's just type in this final problem down here. X to the fourth minus 3x cubed minus x squared plus 6x minus 4. This time it's the same function. What are they asking for? Local max. Now they want to know your local max. Look, you already have it. There's only one relatively high point. This is like the top of the mountain. And it's not truly the highest point on the curve. There are other points that are highest, but relative to the surroundings, it is. That's going to be 0.88, comma, negative 0.94. 0.88, comma, negative 0.94. Guys, that's it. That's your maximum point. And believe it or not, that's all they're asking for in this problem. There were 2 low points, bottom of the valleys. There's just one local max. And guys, we are done.